What the absolute fuck is Hawking radiation? Well, let's find out. Hawking radiation was discovered by Stephen Hawking. He described it as particles popping in and out of existence in the vacuum of space, but when they pop in next to the event horizon of a black hole, one partner goes inside of the black hole while the other one gets to fly away. Well, that is incorrect. And it's not my words, it's his. To understand Hawking radiation, you need to understand two things. First is how a black hole works, and second is how quantum field works. So let's start with a black hole. A black hole is when you cram a lot of mass into a very small space. That's when they usually form, usually at the end of a big star's life. When that core condenses, it forms an outer shell that we see as a black hole. Black holes itself isn't a materialistic thing. It's the bend of space-time itself. That's why we can only see it when it's sucking stuff in, or when the light-emitting star is orbiting it. So black holes are just things that bend space so much that light can't even escape it. Quantum field theory is, imagine this, a field filling up space. Each point is hovering at zero. But when we see a particle, one of those points is not zeros. So it can be an anti or regular particle. So that's what a quantum field theory is. Every single point in that field can become anything. But it usually cancels out because it's at zero. So that means each one of those points have a chance of becoming a particle, but that chance is so small that it almost doesn't happen. How do these two components come together? Well, imagine space-time itself is a string that can be plugged into 8 different nodes and frequencies. And inside that space are virtual particles, one moving forward in time and one moving back in time, and they cancel each other out so we can see them or interact with them. Now, when a black hole is formed, it pinches space-time itself, the string, only allowing 4 nodes to be able to be possible. And that imbalance causes the virtual particles to start forming into actual particles. But where do these particles get their mass and energy from? Well, they get their mass and energy from the curvature of space-time itself, from the black hole. And because of this equation right here, that means that energy and mass is taken away from the black hole, causing the black hole to evaporate. But this energy taken away is just photons, not even formed around the event horizon, but outside of the black hole. And these wavelengths are so big that they're 80 times bigger than the black hole itself. But they have little energy, meaning that the cosmic background radiation itself gives more energy into the black hole than the Hawking radiation gives out. So the black holes grow even if they're isolated.